So 12, part 4 we have to do the vector algebra. Part 4 we were doing in for textbook 10.2. We will continue. So question number 11. Question number 11 is show that vector 2i minus 3j minus 3j 2i plus 4k plus 4k and vector minus 4i plus 6j minus 8k are collinear. You have to show that they are collinear. So let us take this angle as angle A and this is angle B. So in order to show the collinearity, we have to show either B is lambda times A or A is lambda times B. So you can see that 2 to the 4 to 3 the 6, so B can be written as lambda times A. So we can say that, so we can do it B vector B is equal to minus 4i plus 6j minus 8k. For collinearity of vector A and vector B, one vector should be written in terms of scalar times other vector, lambda times other vector, then they are collinear. So here we can take out common. If you will take minus 2 common, what will be left? 2i minus 3j plus 4k, and which is vector A. So minus 2 times vector A. So that is vector B. Vector B can be written as vector B is equal to lambda times vector A, where lambda is minus 2. This implies that A and B are collinear vectors. A and B are collinear vectors. Okay. Similarly, find next question. Question number 12. Find the direction cosines of the vector. Question number 12. Direction cosines of the vector. And the vector is given as I plus 2j, I plus 2j plus 3k. I plus 2j plus 3k. Okay, so what we have seen, this is the a 10.2 question number 12. We have to find the direction cosine. So cos alpha, if a1, a2, a3, then L is equal to a1, magnitude of this one, and m direction cosine will be a2 upon magnitude of this one, and n is equal to a3. a3 divided by magnitude of this one. So that means we have to make unit vector of this one. So first of all, you have to find, just make the unit vector of the given vector. Component will be cos alpha, cos beta, and cos gamma. To find its magnitude will be equal to 1 square plus 2 square plus 3 square. So this will be equal to 1 plus 2 to the 4, 3 3 is a 9. So 14. So magnitude will be 14, and unit vector of A will be equal to the vector divided by its magnitude. It will become a unit vector. So vector is I plus 2j, I plus 2j plus 3k divided by its magnitude under root 14. Okay. So in terms of resolved part, we can write 1 by under root 14i, I component plus 2 by under root 14j y component and 3 by under root 14k z component. So these are called L, M, and N. So therefore here L is direction cosines are, therefore DCs are L is equal to 1 by under root 14, M is equal to 2 by under root 14, and N is equal to 3 by under root 14. Okay, got it. Find the direction cosine of the vector joining the 2 points. So joining the 2 points from A to B, directed from A to B. So question number 13 is also easy. We have to just make the vector and then find its direction cosine. So direction will be given in the question always. You will find the direction always. So A point is the coordinates of point A is they are given as 1, 2, and -3, and coordinates of point B, anywhere you can take. Suppose this is point B, and its coordinates are -1, -2, and 1. And we have to find the direction from A to B. From A to B, this A to B direction, this vector, but we have to find the direction cosines of AB. So AB vector, first find vector AB. So AB vector will be equal to the position vector of B minus position vector of A, and B is OB. Position vector of B is OB, position vector of A is OA. By this way also we can find. So what is OB? OB is minus I minus 2j plus k, vector OB, and minus vector OA is I plus 2j minus 3k, and subtracting minus I minus 2I minus 2j minus 4j and plus k minus plus 3 plus 1 4k. So this is vector AB, and we have to find its direction cosine. So we need to convert into the unit vector to find its magnitude. Magnitude will be under root minus 2 whole square plus minus 4 whole square plus 4 square. Okay, so 2 square is 4, 4 square is 16 plus 4 for the 16. So 16 plus 16, 32 plus 4, 36 under root 36, that is equal to 6. So unit vector will be, now write its unit vector and its components will be, its scalar component will represent the direction cosine, because direction cosines represented by scalar components. So find unit vector of AB. Unit vector of AB is equal to vector AB divided by its magnitude. So vector AB is minus 2I minus 4j plus 4k, and divided by 6. So we can write 6 with each other, 6 and 6. So you can see 2 1 the 2, 2 3 the 6, 1 by 3 I minus 2 2 the 4, 2 3 the 6 j plus 2 to the 4, 2 3 the 6k. So therefore we got DCs are, therefore DCs of vector AB are L is equal to minus 1 by 3, M is equal to minus 2 by 3, N is equal to 2 by 3. Always you can check, I told you always L square plus M square plus N square, it will be equal to 1. Okay. So 1 by minus 1 by 3 square plus minus 2 by 3 square, 2 by 3 whole square. This will be equal to 1 by 9. 1 by 9 plus 2 to the 4. 4 by 9 plus 4 by 9. So 9 by 9, you get 1 always. Okay. So if you have any problem, so that the vector is equally inclined to the x. So how will you find that vectors are equally inclined to the axis? You have to find inclination means direction cosines. So if they have same direction cosines, in question number 14, see question number 14, 10.2. Show that vector, this vector is given us vector I plus j plus k. Okay, we have to show that this vector is equally inclined to the axis. OX means x-axis, y-axis, z-axis. When it will equally incline with the axis, that means direction cosine will be same. Just we have to find the direction cosine. If they are coming same, then we can say that this vector is equally inclined with the x-axis, y-axis, and z-axis. So this is 1 square plus 1 square plus 1 square, that is equal to root 3. So root 3 is the magnitude of this vector. Then unit vector will be equal to the vector divided by its magnitude. That means 1 by root 3. You can see all are equal. 1 by root 3, 1 by root 3 j plus 1 by root 3k. So therefore cos L is equal to M is equal to N, L is equal to M is equal to N. Therefore is A is equally inclined, A is equally inclined with the axis. A is equally inclined with the axis, or x-axis, y-axis, z-axis. With all axes is making same direction. Now question number 15 is based on section formula. Find the position vector of point R, divide the line segment joining the points. Point, if the vector of the point is given, means OP. Vector of the point P will be OP, and it is given as I plus 2j minus k, and OQ, vector OQ is, that means position vector of point Q is minus I plus k plus k, and R is dividing it internally. Internally, R vector is internally and externally both. You have to find internally and externally. You have that formula I told you, MB plus NA. So suppose this is vector A and this is a vector B, and the ratio in which they are dividing is 2:1. Ratio is also given 2:1. That is M is to N. So R, point R, OR, which is dividing internally. So first we will see internally. Internally formula is MB plus NA divided by M plus N. Yes, here M is what, 2, and B is minus I plus J plus K plus N vector A. Vector A is I plus 2j minus k divided by M plus N, 2 plus 1. That is 3. 2 plus 1. So now multiply 2 inside. So minus 2i plus 2j plus 2k, and this n is given us the value of n. Value of n is 1. So plus I plus 2j minus k, and this whole term is divided by 3. So minus 2i plus I minus I, 2j plus 2j, 4j, 2k minus k plus k divided by 3. This is what internally. And if you have to find externally, so in externally division, that means that point R is outside AB. So OR, the formula will be M vector B minus N vector A divided by M minus N. So here M is 2 into minus I plus J plus K minus 1 into I plus 2j minus k divided by 2 plus, no, 2 minus 1. 2 minus 1, m minus 1, that is 1. So minus 2i plus 2j plus 2k minus I minus 2j and minus minus plus k. So answer will be minus 2i minus I minus 3i plus 2j minus 2j cancel, 2k plus k, 3k minus 3i minus. Find the position vector of the midpoint. This is the position vector which is dividing the two in the ratio 2:1 externally or internally. Now if they will ask midpoint in the next question, they ask the midpoint. So midpoint also we can find the midpoint directly. Position vector of the midpoint formula is, I told you, a plus b by second. Next question you can do it. Question number 70, show that the points form the vertices of a right angle triangle. Yes. Question number 17. Question number 17. Show that the points ABC whose position vectors. So position vector of point A is equal to 3i minus 4j minus 4k, and vector B equal to 2i minus j plus k, and vector C is I minus bj minus 5k. We have to show that these points, these are the position vectors of the point OA, OB, and OC. So we have to show that this forms a right angle triangle. The position vectors. So this is the position vector of A, that is OA. This is what? OA, vector OA. And this is what? Vector OB. Okay. And this is vector O capital C. So ABC, if you will take 3 points, because this is making a right angle triangle, just roughly we can take any right angle triangle. Suppose we don't know which is hypotenuse, but suppose this is A, this is B, and this is C. Okay. Now you have given this position vector. So this is x-axis, suppose y-axis and z-axis position vector. So this position vector OA, this will be the position vector of A, OA, and OC is the position vector of this one. Okay. So OA, position vector of this, then position vector of C, and position, okay. Then ABC is a triangle. This is right angle triangle. We suppose, because we don't know where will be the hypotenuse. So now just I want to show you that we have to find AB. First we will find AB, then we will find BC, then CA. We will find vector AB, then vector BC, then vector CA, and their magnitudes. Then we show that it is making a right angle triangle by using Pythagoras theorem. So first we will find AB. Okay, so vector AB will be equal to OB minus OA, OB minus OA. OB is this one, OB minus OA. Is, if I will write directly, so 2I minus 3I minus I, and minus J minus 4J, 3J, and K minus 4K, 5K. This is AB. Okay. Then write BC. BC is OC minus OB. I minus 2I minus I. Then minus 3J minus plus 1. So minus 2J. Minus 5 minus 1 minus 6K. 2J minus 6K. And CA, vector CA will be OA minus OC, or you can say vector A minus C also. Vector A minus vector C. So vector A minus vector C, 3I minus I, 2I, and minus 4J minus plus 3J. So minus J, and minus 4K minus 5 minus 5K, 5K only. Okay, now we have to show it is making a right angle triangle. So we have to find their magnitudes. So find their magnitudes. Find their magnitudes. What will be the magnitude of AB? Magnitude of AB will be equal to under root 1 square 1 plus 3 square 9 plus 5 square 25. So under the root 35. Then find the magnitude of BC. BC. That means the length of the side. Magnitude of BC means length of the side. And one more method is there. You can find the dot product of these three. One of them, dot product A dot B. We have also seen that what is A dot B? A dot B is equal to AB cos theta. When theta is equal to 90 degree, when theta is equal to 90 degree, cos 90 degree is equal to 0, A dot B is equal to 0. So if you will find the dot product of this A, B, B, C, C, A out of these dot product, then A dot B, B dot C, C dot A. In any one, if you are getting 0, that means it is a right angle triangle. One of the way of doing this by using dot product also. And BC, 1 square minus 1 square, 2 square, 4, 6 square, 36, 41, root 41, and the last one has magnitude as 2 square 4, 1 square 1, 1 square 1. So this is 4. 4 plus 1 plus 1. 6. Now you can see this is the highest value. So greatest value square of this should be equal to the sum of the squares of other two sides, then it is a right angle triangle according to the Pythagoras theorem. So you can see that 35 square plus root 6 square. So that 41 square is 41, and here 35 plus 6. So 35 plus 6 is equal to 41. Therefore, A, B, C is a right angle. Form the vertices of a right angle. A, B, C are the position vectors of A. You have to write A, B, C. Form the vertices of a ABC, form the vertices of a right triangle. Okay. And if you want to do this one, you have to check A dot B, B dot C. For this one, you can find the, you have ABC 3, so A dot B, A dot B, B dot A, same thing. Then you check B dot C, then you check C dot A. So one of them will be 0, one of them will be 0. That shows that it is a right angle triangle. So one of them will be equal to 0. Okay. So that shows also that these points form the vertices of a right angle triangle.